Hi everyone, welcome back to Perception Paradox. My name is Jivila and I'm your host. And today's guest is Duncan Casey. We've met with him back in March 2026 during the EIC Growth Summit happening in Paris. And I don't know, it was just so interesting. We had lots of great laugh, conversations about science, how he's working with those space lasers. And I was like, whoa, I really want to bring you on Perception Paradox podcast because your story is super cool. He's been doing so many cool things when it comes to science. So he's a photonics engineer, a serial founder, a science communicator, and the kind of person who turns a broken lab machine into $100 disposable device just because he was tired of repairing it. And we talk about what it means to build before anyone believes in it, why being generalist is a superpower, and how scientists should think as CTOs and a bit more from a business perspective, and what happens when you follow curiosity instead of a career plan. So if you're into science and want just to learn more about the space satellites and pick up a bit of the Duncan's brain, this episode is for you. And I would say let's dive in. Real people, real stories, and real challenges that break the status quo. I'm your host, Jivila, and welcome to Perception Paradox.
I mean, I'm basically just quite bad at quite a lot of things. So, I mean, I work in a satellite laser communications company nowadays. We build space lasers, which, like, one day I might get bored of saying, but it's not going to be today. My son is 9 and thinks it's the coolest thing in the world. I'm a geek, let's be honest. But I started out life as a chemist and then moved into medical devices, and I started some tech companies, and I tried being an academic for a while and gave that back. Built a bunch of tech companies and wound up moving to Ireland about 5 or 6 years ago. And like I said, space lasers. Beats having a real job.
Whoa, Duncan, I couldn't imagine a better introduction of yourself and welcoming to Perception Paradox podcast. So I guess we go straight into that. Welcome. Thank you for sharing. Thank you for being here. So we've met with you in Paris.
Yes.
During the conference. And I remember, like, what struck me, first of all, we ended up being this cool, fun group of people who got lots of laughs. And then you started sharing those crazy life stories of you being bad, or I would say good at so many things across chemistry, biology, physics, engineering. That's what you've just saying, right? And most people think that expertise means going deep in one thing, whereas in your case, it seems like you're just very curious, geek, and you go where your curiosity drives you and interest in science. So how did being a generalist, and I think that's a good opening question, became your superpower? Because that, it seems like that is your superpower.
So, I mean, an awful lot of what I do is taking stuff that other people have invented to solve other problems and applying them to what I'm working on that day, right? So it just helps to be able to speak a lot of languages, right? It turns out that a lot of problems in medicine or engineering or AI or whatever have already been solved by people who make window glazing or who build houses or who, right, or who make centrifuges or whatever. But the thing is that everyone writes in such specialized jargon that unless you've got somebody who can speak all the languages, or at least can fake it, it's very hard to pull those things apart, and you wind up reinventing the wheel all the time. So, I mean, people tend to come to me when they've got 4 or 5 different things that feel like they should fit together but don't. That's kind of where I'm useful. I mean, here I'm doing material science for large-scale production of tiny photonic microchips, so that we can do inter-satellite communication over, I don't know, 30,000 kilometers. And some of there's really quite detailed engineering involved in the microelectronics and the little photonic systems. If you haven't encountered it, photonics is to light what electronics is to electricity, right? Optics is this flow of light down beams. Photonics is cutting it into little ones and zeros, essentially. So in the same way that electricity can look like lightning, or can be ones and zeros on a microchip, it's the same kind of concept. But we're trying to take that extremely finely detailed engineering and relatively cutting edge science. There's no real industry for a lot of this stuff yet. And then mass produce it, and then chuck a signal over 30,000 kilometers between two satellites that might be doing 50,000 kilometers an hour in opposite directions.
Wow,
It's fun.
that's wild.
Beats having a real job, like I said.
How do you direct yourself when you're working on such a big project and such something that requires a speed, huge capital, thinking about the also external environment and the dangers potentially? How does your life look like now while working on that?
So it's kind of like weaponized ADHD, to be honest. So this isn't me sitting as a lone genius in a cupboard thinking deep thoughts. That's not really how it works, right? So I've got a team of people who are much smarter than I am, who tend to be more specialized, and then my job's to bring them together. So there's a bit of that. One of the big challenges when you're taking something that's relatively recent science to industry is that there's nobody who's done it before. And it's a very different mindset between I'm going to sit in an academic lab and produce a one-off prototype that will be the first of its kind in the world and will be amazing, versus I need to make 50,000 of these by next Tuesday. This is my acceptable failure rate. The idea of going to a design freeze where you say, we know it's not perfect, but it's good enough. We can make these. It satisfies a customer requirement, so we can make these. And then the next generation will have all the extra widgets we want. And then we'll freeze that because it's good enough. And we'll iterate like that. So you're selling your iPhone 2 and 3 and 4 as opposed to trying to make a single perfect, unique and beautiful snowflake. And that's a difficult mindset if you come from a research environment. So again, a chunk of my job there, and the reason I wind up double hatting between business development and photonics is that it's very hard to get people who are excellent at photonics and excellent at business, or have even industrial experience of business, right? So my job is to try and bring those things together.
So how can we do it? Because very often, let's say in the startup world, and when it comes to deep tech and science and innovation, we can see, let's say, investors coming and trying to make scientists CEOs or change a bit the way they think and they build. So, and you're kind of in between, like connecting in business and science together and trying to create this common language. What would you say from your perspective? Who had been in both sides? How do we do that? How do we commercialize and how do we grow?
Again, I've been bad at all of these things. So I've been an academic, and I've been a CEO, and I've done technology transfer, and I've done investment panels. So, and like I said, I'm bad at all of them. So I get to be rude about everybody. All the things that make you a good academic make you a bad CEO, right? The drive towards perfection, and the secrecy until it's perfect, and the deep learning approach where you have to do it all yourself, or your PhD students have to do it all themselves. All of those things are actively harmful if you're trying to get something built on time, to budget, to meet a customer demand. The other thing is that the making a perfect shiny thing that's accurate to 99.9999999% in commercially nobody cares, right? The startup world is littered with academic startups where Professor whatever has invented a shiny thing and then has gone around the world trying to hammer their shiny thing into different shaped holes in the marketplace until one of them fits. And it just turns out no one cares. So academics, and particularly PhD grads, early postdocs, thereabouts, make very good CTOs. I mean, I started my first tech company when I was a final year PhD student, and that was probably too late. By that point, I had been an academic for essentially 4 or 5 years, which meant I had all this scar tissue, all these kind of ingrained habits about what makes a good academic, and that made me a bad startup CEO, right? It did. And it took me 18 months, maybe more, to chip that off, to try and start getting at the practicalities and the realities of the trade underneath. But that it does work quite well, turning those people into a CTO, particularly if you can do it as part of a PhD training program, right? So you don't have to. You don't need a PhD. There's no magic thing about those extra letters on your business cards, right? You can't eat them. You can't eat them. You can't spend them. I've tried. A PhD is a useful apprenticeship in some sectors. Oh, you're still there. There you are. You're back.
I'm still here. I was like, the moment of pause. I was like, but if you could see yourself moving, then it means that it's recorded, so it's fine.
Okay, great.
Have it.
To be honest, I have the perfect face for radio. It's fine. So you don't. There's nothing magical about a PhD. It's an apprenticeship for a particular kind of career, and you probably want one if you're going to be in biotech because you can get that badly wrong. And you probably want one if you're going into quantum computing or quantum photonics, because that's basically black magic. And it takes a while to learn all the incantations and rituals. Quantum stuff only works because it can't read the books as it can't. But for an engineering post or a software job, for example, you don't need one. You will learn more by doing it a bunch of times. And some of the kind of iteration discipline, if that makes sense, the kind of doing it and improving it and doing it and improving it process that you get from an engineering post is probably better value. So it depends on what you want to be when you grow up. I still don't know.
Me neither.
But I get bored too quickly. But I used to be on the management team of a materials research institute in the UK, in the city of Bristol. And that worked very well because we had all of the students working on industrial challenges. We'd go out on the road, or I'd go out on the road, talk to people, buy lots of drinks, shake lots of hands, to find out what people in industry and in startup couldn't do but would love to do. And then I'd go back to the university and say, here is a smart student we found, here's a bag of money to fund them, and here is a problem that's genuinely costing industry or society money or pain or whatever. Make them all go away. And so those students would work for the next 3 or 4 years on solving that problem with expert supervision from academics. But it might be 2 or 3 academics, each of whom contributed a little bit of the Venn diagram. Right? And while they were doing that, we'd train those students in how to think like a CTO almost from day one. And we'd get them working on industry or on startup business cases. So way back in the mists of time, Jesus, years now, I have been one of those technical founders with a shiny prototype product, a cheap suit and dubious personal hygiene, bouncing around on stage, trying to persuade investors to give us money with absolutely no concept of product market fit. Absolutely. No idea about why people should give us money other than that it's a cool thing and it's really shiny and look, it does something we think is great. Again, it's some of that's academic scar tissue. And while I was helping to run the centre in Bristol, we started to see some of those companies bubbling up. The people who were smart and driven with plausible prototypes that just didn't fit what customers wanted, but didn't know how to make that connection. And so we trained up the PhD students in the centre as business consultants. They would work for free in a consulting company, but the consulting company got paid. The students got a daily stipend, essentially, got a bit of pocket money. Wasn't too bad pocket money. To go and train, to go and do this business strategy consulting for these companies. The companies got 30 or 40,000 euros of free expertise, essentially. The students got genuine immersion in the professional world of business development, and then once they'd done the training, they could do follow-on work with those companies if the companies wanted to buy back in, for which they did get paid. And lo and behold, these guys would use their PhD holidays to train as business developers and business managers while learning technical excellence and the kind of scientific skills of the PhD. And 3 years later, as they all graduated, they all started tech companies. Not least because their projects had all been built around a genuine customer need.
Wow.
And so that started to produce, off a cohort of maybe 10 or 12 students a year, we were getting 3, 4, 5 startups a year, right? And that was fun. Some of those are doing really quite well. At least one of them owes me a yacht, right?
So what would be the major thing and skill you learned while making all those mistakes and raising money from the different perspectives from investors?
Well, the Simpsons scene with the rakes, a bit like that, right? I mean, learning by doing, they're calling it. Learning by walking, bumping into stuff, falling in holes. I guess the biggest takeaway was that the solutions don't have to be magic, right? That first company I started remains to this day the dumbest thing I've ever designed. Jesus, it was stupid, right? But it worked. It worked really well. And what I was doing at that point was, so during my PhD, I was studying how drugs get around your body. You take a tablet, it hits your stomach, and then your headache goes away. All right, fine. How? Why? Because the medicine is in your stomach, the receptors are in your head. How does it get from A to B? And people say, oh, it moves in your bloodstream. But if you take, I'm a chemist, if you If you take a drug molecule, a little pile of drug powder, and you pour water on top, nothing happens. Most of them aren't soluble. Most of them will dissolve in oil rather than water, right? And yet you take a tablet and some magic happens and your headache goes away, or your big toe ache goes away, or whatever. Your infection evaporates. And so we were investigating how that worked, and the least bad, and I choose those words carefully, the least bad way of doing it was a chemical separation technique that we were using to look at cell membranes, which are basically like biological washing up liquid. Everything dissolves in washing up liquid. That's the point. It turns out your body uses them to wrap up your cells. So it's useful stuff. But it's also like dried out washing up liquid. It's gloopy and gunky. And this chemical separation technique involved squeezing high pressure solvents through piping with a diameter of my hair or your hair with this gloopy, gunky analyte in the middle, which meant mostly what I've got is a PhD in repairing broken analytical machines, because we put the sample in and run it for a while and it would go bang, and suddenly it's raining bits of analytical hardware. And so one day when it was lying in smouldering parts around my feet and slightly blackened walls, I thought, screw this, and I took it to bits, or what was left of it to bits, and it came in all these kind of shoebox-sized components, each of which was 20 or 30,000 euros a pop, right? Jesus. So I took each one to bits to try and work out what it did. Not how it did it, but what it did. And then I made the stupidest bloody thing I could think of that would serve the same function. Each component, one at a time, what's the dumbest, cheapest, nastiest way I can think of that delivers the same function, right? And then I bolted them all together, and it worked, which was a surprise to everybody. And in fact, it had, because of luck, mostly, some of the cheap, nasty, stupid techniques I'd come up with or I'd been able to track down actually gave better resolution than the laboratory one did. And it did so in a way that was very cheap to produce. The first one was expensive, but the second one was free, and so was the 10 millionth one, right? It was very cheap to do. And I'd accidentally turned £250,000 worth of analytical hardware into $100 worth of fluidic that would fit into a cigarette packet. Purely because I was trying to never have to repair one of the bastards ever again. I simply wanted to be able to throw it in the dustbin when it failed, unwrap another one and press go. But then me and my co-founder spent the next couple of 3 years trying to work out who actually, we'd made a thing for us, right? And some people, some investors and some research leaders in the university, Imperial College, where I was at the time, who I will be eternally grateful for setting me on this road. We'd made a thing for us, which had a market of exactly 3, which was us. Then it was a case of trying to work out where that functionality had market value. And the value wasn't in all the things it did could be done already, right? But they could be done by somebody like me who had a PhD in driving the hardware, right? By making something disposable, what we'd done was make a thing that could be driven by anybody. We turned £250,000 worth of analytical hardware into a pregnancy test kit. Right? There's quite a lot of sophisticated biochemistry and bioengineering goes into a pregnancy test kit, but at the end of it, you piss on it, and it tells you if you're pregnant or not. Right? You don't have to know. You don't have to know how it works. It does one job and does it really well. Right? And what we'd made accidentally was one of those.
No way.
I wouldn't use it for pregnancy testing because we can do that already cheaply, but it was that kind of model, that kind of concept. You want to test for aflatoxin, for example, a fungal toxin that grows on tropical crops like peanuts. And it's a bugger because it only has to be there at parts per billion, because the fungus, by the time somebody actually eats it, there's a lot more of it, right? Because it keeps growing, because it's a fungus, yeah? And so you want to detect it as early as you can at very, very high sensitivity. But if you have to take a sample, grind it to powder, ship it to an analytical lab in Cambridge or somewhere, right? And then get the data back, it's already entered the food chain by the time you've done that. So what you want is something that can perform that kind of function at point of testing. And so that's where we took the idea. The other thing that I guess I learnt from that process was don't do platform technologies. Solve problems. Right? Every academic in the world, every university startup in the world says, look, we've made this amazing thing that can be applied to every problem on Earth. First off, no, it can't. And secondly, that means you have no first customers. You have lots of second customers, but no first customers, because everyone else wants somebody else to take the risk. Yeah? So solve problems, and you can solve 10 different problems with the same technology in 10 different coloured boxes at 10 different price points, but you solve problems. And that way people know what it is you're selling and what they're investing in.
Golden words for sure.
Maybe, like I said, mostly scar tissue talking.
But then Duncan, after in so many different kind of directions, all related to science, how did you end up in the lasers?
In space lasers, well, somebody said, would you like to work in space lasers? I mean, that mostly did it. So while I was on the management team of this centre in Bristol, like I said, we used to go out, or I used to go out particularly, on the road to technology showcase events and startup events and industry events to find what people couldn't do. And one of the ones I went to was in Ireland. There's a National Institute for Microelectronics and Semiconductors called the Tyndall Institute down in Cork in the southwest. And I went to one of their showcase events that was held in a sports stadium that I couldn't pronounce, and still can't to this day. Which language is quite something coming from a UK background. And I looked at a whole bunch of technologies and a whole bunch of things that kind of nearly worked, or that, again, were being developed for academic track projects. In some cases were being developed with genuine industry input that looked really good. And then afterwards, rather the way we met, I went to the drinks mixer thing, and that in Cork tends to go on for a little while. It's quite good fun, that town. And we were in a bar called the Oval in Cork, and I was sat next to a guy called John Mackey, who was in a company of, at that point, 4 people. This is about 2018, who was telling me how they were building systems for space, and how a company in the west coast of Ireland was going to revolutionise the international communication market by shooting lasers at each other. Go on. So over 300 or 400 pints of Guinness, probably no more than that, we put the world to rights and planned out world domination. And then I kept in touch with the company over the next 6-7 years, whatever it was. It helped a little bit with some fundraising and finding some key hires. If I had a good student or a good graduate coming off who wanted to work in the sector, I'd send them across. So we kept in touch. And then I moved across to Ireland from the UK in 2020 for reasons you can probably work out yourself. It all got a bit Brexity. It was time to be elsewhere. And I've always had an Irish passport, so it seemed a shame not to use it. So I was working in a university in Ireland running technology transfer processes, and it was all a bit slow and a bit conservative. And I thought, hang on, those guys who made space lasers, they were just up the road. I wonder. So I gave John, the CEO, a ring and said, I don't suppose you need a kind of idiot to come and run your business side, do you? And he said, funny you should say that. When can you start? And here I am. So I moved across. My family and I moved across to Galway. It's an absolutely beautiful region. I can see the Atlantic Ocean from my bedroom window, which is not the worst thing in the world. The city is only 80,000 people, but feels a lot bigger. So it feels like a proper city. But you can cycle for 10 minutes and be stood in fields talking to donkeys, or you can have wet feet with your toes in the Atlantic. It's fantastic. So it's not the worst corner of the world to who landed it.
Wow, what a story, Duncan. So my follow-up question would be not only about the space lasers, but also what does it feel like to be in the industries that nobody else sees it, like be the frontier who is working for something bigger than we can imagine in our regular life? How does it feel when you cannot just say, okay, like next year we're going to get to this target and we're going to come up with this kind of outcome? Because I assume it's lots of uncertainty is also involved in the work you do, guys.
I mean, it is, but it's still problem solving. It's still just rather as, I mean, there's an old Henry Ford quote about if he'd done what the customer wanted, he'd have been making faster horses. That I've always felt was a little dishonest, right? What you're doing is identifying the problem and then building the right tool to solve it. Again, what typically happens with a university-led startup is they have invented a technology and then go around looking for a use for it, right? But like I said, the way that works is to go the other way around. What's the identify a problem and really, really, really identify a problem, so you understand it at quite a granular level, and then the technology you need to address it becomes fairly obvious because you've eliminated lots of others down the way, right? Most of the other alternatives have been eliminated, so you're left with a choice of 2 or 3. Take your pick, right? So it sounds pretty dramatic, right? The building space lasers, cool. I might say it some more. I quite like the sound of that. But the reality is that if you want to do high-speed communication to anywhere, it's one of very few options you have. So if you've got a 5G phone or the 6G stuff coming up, all the millimeter wave signals in radio frequencies, they start to creep closer and closer to the frequency your microwave uses to heat food. And the reason your microwave uses those frequencies to heat food is that water absorbs them really well, which is a problem for beaming through the air because the air is wet, particularly if you can see the Atlantic Ocean out your window. It's really, really wet. And so the absorption of radio frequencies of high data rate radio signals by the air is really high, which means you might have noticed over the last 5 or 6 years, you see a lot more mobile phone junction boxes, mobile phone repeater boxes. That's because the signal, 2 or a 3G signal, will travel 4 kilometers, but a kind of millimeter wave 4G, 5G signal will travel hundreds of meters, and then you need another repeater. Okay, I mean, that's fine in a city, but as soon as you start getting out of town, you still need repeaters, and it starts getting stupidly expensive. Or you have to run fiber optic cables under the ground, which is again expensive. It's digging up a big chunk of real estate to lay a fiber this big, right, to do the repeaters at the far end. It gets very expensive and very impractical very fast, certainly anywhere with a diffuse community. Outside of any major city, it stops working quite quickly. So what you've got to do is be able to, you want something that gives you all the benefits of fiber optic communication without the fiber optic communication. At that point, what is lasers. But when you try to chuck lasers through the air, there's a load of air in the way, right? And have you ever looked at sand on looked at the desert or looked at sand on a hot day, or even at the seaside, and you get that kind of shimmering reflection on the shimmering mirage on the horizon, right? Lasers see that too. And the more air you want to go through, the more of a problem that becomes, the more it distorts that signal. So you can think of this laser communications as basically being really fast Morse code. It's ons and offs, zeros and ones. It's just really quick Morse code. But that means if you've got a shimmery thing in the way that's disrupting your on and off signal, your dots and dashes, right, then the signal turns up as garbage. So the only way to do it is to beam those signals through something where there's no air. Fortunately, 99.999% of the universe has no air in it. So we use that bit.
Mm-hmm. That's wild, I have to tell you.
But it's just the conclusion makes you sit down and think, oh, geez. But the steps you get to it are just straightforward. So we can't do this. Yeah, we've got to do this. We've got to do this. We've got to do that. We can't do this, or this. What's left? We're going to space then. That's all it is.
How is it going to build the company in Europe? Like, we've been talking a lot in the ecosystem about lack of funding, especially for deep tech startups. And now we've got quite new initiatives, but we are still behind the US. That's where usually we compare ourselves. So how is it going for you, and what would be your take on that?
So the early stage capital scene has got a whole load better in the last 10 years. It really has. If you want to do anything up to about 10 million quid, right? 10 million euros, then there are a whole bunch of viable routes to do it. There's loads of money in software and whatever, and like, from an investment standpoint, I understand it, but to me, it's boring, right? Who cares? You're not gonna change the world by making a data analytics engine for the insurance industry or whatever. You can make money, but yeah. But if you want to do deep tech, genuine deep tech now, there is money around. There's plentiful money around for seed rounds and for A rounds. The trouble is you wind up in the situation then that the UK economy found itself in a few years ago, where you have lots of startups, lots of people getting to reasonably high TRL 6, 7, 8, whatever, needing to go to scale and needing a B round of 50 million euros, 100 million euros, 200 million euros. And there is nowhere to do that in the EU. There's some really welcome initiatives from the Commission, from the EIC, the like, but those are really funds for closing around. We make telephones, right? We make complicated, expensive, very quick telephones, but some of the people who want to move signal through those are national governments. Some of them are doing Earth observation. Some of them are doing secure communications for whatever reason. Some of them are doing kind of missile shield tracking or whatever, right? You get the idea. So the signal is a signal. We don't care what it is, but intrinsically it's dual use, which means intrinsically you're subject to ITAR and to export regulations and whatever. And as soon as you set down a base in a different country, a different set of rules apply. And suddenly it's very hard to sell to your previous customers or whatever. Right? And so all of these complexities intertwine. We would love to keep this company. We'd love to keep it based where it is. It's a really lovely corner of the world. I don't know how practical that'll be, right? We are building out really serious capacity here. We are doing our level best to keep it here. We'd love for it to be at least majority European owned. Right? We'd love to turn it into to really move the dial on Irish GDP. So, I mean, you're probably aware that an awful lot of Irish GDP is dominated by multinationals or US companies who have their headquarters here for mysterious reasons. Who can say? Who can say? We'd love to have a genuine Irish-built deep technology company based here, making a really significant contribution to the Irish economy, right? We're employing anybody we can find who wants to come over and do it. But the reality of it is that an awful lot of the customers are going to be US based, and an awful lot of the investment funding we need to scale it up to satisfy those customers is going to be US based. And that comes with a whole tranche of strings.
Very well. Do you have a big competition out there?
Less than you'd think. Less than you'd think. So we don't make satellites particularly. We make ways for satellites to talk to each other. So, and people on the ground to talk to satellites and data within satellites. So we do this kind of full stack data communication service, data communication hardware for people building satellites. Most people who want to do communication satellites know how to do satellites or know how to do communication, right? What they don't have is the specialized tools for doing it in space. So by that I mean, okay, if you have a really massive constellation, like we can draw names out of a hat, right? If you have a really massive constellation with everything flying around in formation, your tracking is relatively easy because the satellite in front doesn't move and the satellite behind you doesn't move relative to your frame of reference. So once you found them, you found them. And everything is, if not easy, at least predictable. But if you want to link between satellite constellations, or between a satellite in low Earth versus mid-Earth versus geosynchronous orbit, right? That gets a lot harder because you're moving at different speeds. Now, I don't know if you're familiar with the Doppler effect, but you know the sound of an ambulance coming towards you. That's the Doppler effect. And it's not actually making that noise. Its tone is static. But as it's coming towards you, the sound waves bunch up and get higher frequency. And as it goes past you, the sound waves are stretched out and get lower frequency. So you get this two-tone effect. The same thing is absolutely true when you have two satellites coming towards each other, right? Or moving at different speeds, whatever. But coming towards each other is easy to visualize. They're coming at each other. They might be doing 40,000 kilometers an hour each, right? They might be really shifting. So you could have a difference of velocity, a delta V of 80,000 kilometers, 60, 70, 80,000 kilometers an hour. Now that ambulance pitch you hear might be doing 60 kilometers an hour, right? So 60,000 kilometers an hour is quite squeaky, right? It makes a real difference to the frequency of that signal. And in optics, that means it changes color, which is remarkably bloody annoying when you're trying to pick a signal, long thrown signal, out of a noisy background full of stars, and one big one in particular that's glowing quite close by, and reflections off planets of all different colours. You're trying to pick out the little bit of that signal that you really care about, but the colour keeps bloody changing. And that's a really difficult thing to do. There aren't very many companies on Earth who can do that. Certainly not if you want to go fast. Doing it for relatively low data rates. So the broadband that you have at home is probably 1 gigabit per second.
Mm.
If you want to go at 2 gigabits per second or 10 gigabits per second, that's not too difficult to do. And there are a number of solutions out there that do that, a number of providers who have technologies in that space. But if you want to go at 100 gigabits a second or 800 gigabits a second, that's a lot harder and requires much, much finer detection, you need to be able to kind of use a pair of tweezers and pick the signal you want out of this fuzzy background. And there are, I think, about 4 companies on Earth who can do that. Hi, we're Mbryonics.
Love it. A great pitch, Duncan. Impressive what you're working on, and impressive also about you going around so many different kind of angles and areas. We're getting closer to
Indecisive.
and is indecisive. Well, we're getting closer to the end, and I have a couple of questions for you left. So one of them talking about your indecisiveness. How do you deal with the stress, uncertainty, and how comes that where is that courage to go for things that are unknown?
I've tried working in big corporates, and I'm rubbish at it. I'm not very good at singing the company anthem and using the company phrases. It's not really my scene. So I like it scrappy. I mean, a part of it is that once you start to recognize your skill set, first off, you can round out the edges, but also I'm reasonably useful in 4 or 5 different sciences or engineering fields. Worst case, I can start a new business. I know how to do that now. But I can go into somebody else's company and help them make the most of what they're doing, help them to understand the environment they're working in, help them understand what the customer is actually saying when they say, this doesn't work, or we need something that does that. I can help them make the connections with investors or funders or state bodies or whatever, right? So I don't typically have to look for work for too long. I'm profitable for just about anybody who hires me. So that's a comfortable place to be, right? Don't get me wrong, there's always risk. Any startup, any scale up is dealing with 3 existential threats before breakfast, right? But the reality is there's enough diversity in the marketplace. There's going to be something that's going to be fun to do. And also, I mean, I worked at universities in and out, on and off, Jesus, I guess 10 or 15 years, right? Not counting the training bit. And in most of that time, I was on contracts of no more than a couple of years. But a couple of years was a long contract. It's not like there's some massive difference in the stability. You can have a postdoctoral research contract or a tenure track, lecturer grade post, whatever, and you're on a 3-year contract. You can't get a mortgage on one of those either. So in some regards, when I'm doing this, I'm master of my own destiny. If these products succeed or fail, a lot of it's on my shoulders. And if I screw it up, it's my fault.
Okay, it seems like you've built your confidence over the years, having...
It's got a massive ego, that's all it is.
Massive
an ego big enough to look after itself.
Yeah, but I think that's great that you're so aware of your strengths and what kind of value you can bring, and you're just owning it. And also just, yeah, there is nobody who can do that instead of you, so you just have to do it.
No, that's not. I mean, every single thing I know how to do, you can find someone better than me. What there aren't very many of are people who can do all of it, right? Who can speak the language between the engineers and the accountants and the investors and the regulators and the whatever, right? That's a bit that I can bring to the party that not many other people can be bothered with.
Wonderful. Okay, so I think what we're taking from this, that self-awareness and confidence is the way to go, and for sure. And then one more thing. You've been doing lots of different initiatives, right? When we met, you were sharing with me your Glastonbury experiment with the water pipes and kind of identifying it as lasers and so on. So my question would be where is that playfulness come from, and wish and dedication to work with students, with kids, with this kind of for educational purposes?
Why would you do stuff if it wasn't fun? People say, oh, I don't go to work to have fun. Jesus, you're doing it wrong, mate. This is fun. And like, I am fully aware that I'm here because a number of people gave me opportunities to do things. A number of people recognized that I was interested in something a bit off the wall and spent the time and the effort to help me learn it, to help me get good at it, to let me play with it, to give me access to toys that I've got no right to have been working with, right? And so a part of it's just paying it forward, right? But the other thing is, from a purely self-interested point of view, this company's growing really fast. People that we want, the skill sets that we need, don't exist in very many people. So if you want it to exist, give people a reason to go get them, give people the opportunity and the access to make it happen. Because otherwise, you can't complain that you're struggling to recruit people if you aren't contributing to the training of the next generation coming up. But it should be, most of anything, it should be fun. If it isn't fun, if it feels like a lecture, if it feels like a drag, like a science class, you're doing it wrong. It should be fun.
Okay, love it. Fun is the way to go. Okay, I have a tradition in the podcast to leave the listeners with a thought to ponder. So, what would be your thought for everyone who is here with us today listening and maybe they need some a bit of more credentials or permission to pursue? What would you tell them?
Find the problem you're solving. Understand the problem you're solving more than anything else, more than qualifications and credentials and whatever, credibility. If you really understand the problem you're solving, then you will work out how to solve it. There's nothing magical to it. You don't need a PhD in whatever. You don't need a supercomputer or an AI engine or a quantum thing. You need to understand what problem you're solving, and from that, the solution to it will jump out. But if you can't work out what the solution is, you don't understand the problem well enough.
Here we go. I couldn't imagine a better way to end this episode. Duncan, thank you so much for joining us today on Perception Paradox. Great values, great insights. Hope to see you soon, and thank you everyone who joined us today. It was Perception Paradox, Duncan Casey, and yeah, see you next week.